In 16th century Italy, an age of art, faith, and certainty, people believed the earth stood still at the center of everything. The heavens turned above them, perfect and eternal, their motion seen as proof of divine order. It was a comforting idea, a universe designed around us, unshaken for more than 1,000 years. It was a truth inherited, not discovered, a reality accepted, not questioned. But in this world of certainty, one man was about to look up at the heavens and ask questions that would forever alter our place in the cosmos. His name was Galileo Galilei. Born in Pisa in 1564, Galileo was a man of his time, a devout Catholic, a brilliant mathematician, and a natural philosopher with an insatiably curious mind. His early years were spent not gazing at the stars, but studying medicine and later mathematics. He was a polymath, drawn to the mechanics of the world around him, from the swing of a pendulum in a cathedral to the trajectory of a cannonball. He was a pragmatist, a hands-on inventor and teacher, whose mind was always searching for the how and why behind the observable world. The cosmos, for a time, remained a distant theoretical realm, a subject for philosophers, not for practical men of science. But whispers of a new idea were already crossing Europe, a radical theory proposed by a Polish astronomer named Nicolaus Copernicus, suggesting that perhaps it was not the Earth, but the sun that stood at the center of the universe. For most, this was a mathematical curiosity, an interesting but unproven hypothesis. For Galileo, it was a seed of possibility planted in fertile ground. The year 1609 marked the turning point. News arrived in Venice of a curious Dutch invention, a spyglass that made distant objects appear closer. While others saw a novelty for sailors or a toy for the wealthy, Galileo saw a key to unlock the secrets of the heavens. With his characteristic ingenuity and skill, he didn't just copy the device. He radically improved it. Within months, he had crafted a telescope far more powerful than any in existence, capable of magnifying objects 20, then 30 times. He turned this new eye not towards distant ships, but towards the night sky. And what he saw would shatter the pristine, perfect celestial spheres of old. He pointed his telescope to the moon. For centuries, it was believed to be a perfect, smooth orb of ethereal light. Galileo saw a wild world, full of rugged landscapes, with huge craters and tall mountains casting long shadows over sunlit plains. It was a landscape not unlike Earth's. The celestial and the terrestrial were not so different after all. This first discovery was a crack in the foundation of the old cosmos. Then he turned his gaze to Jupiter. Night after night, he observed the giant planet and noticed 4 tiny points of light accompanying it. They weren't fixed stars. They moved. They danced around Jupiter, disappearing behind it and reappearing. He meticulously tracked their orbits, realizing with breathtaking clarity that these were moons circling their own planet. Here was irrefutable proof that not everything in the universe revolved around the Earth. A miniature solar system existed, a model that directly contradicted the established geocentric view. The 4 Medicean stars, as he named them in honor of his patrons, were a silent, powerful testament to a more complex reality. His most decisive discovery came when he observed Venus. According to the Earth-centered Ptolemaic model, Venus should only ever appear as a crescent. But Galileo's telescope revealed something astounding. Over the months, Venus went through a full set of phases, just like our moon, from a thin crescent to a full round disk. This was impossible in a system where Venus orbited the Earth. The only way to explain these phases was if Venus revolved around the Sun. This was not just a suggestion. It was observational, geometric proof. The Copernican heliocentric model wasn't just a theory anymore. Galileo could see it. He had witnessed the architecture of the heavens, and it was not what he had been taught. Galileo published his findings in a small book called The Starry Messenger, which became an instant sensation across Europe. He was celebrated as a visionary, a modern Columbus who had discovered new worlds. His discoveries challenged many of the accepted ideas of his time, including those supported by the Church. For centuries, the geocentric model was not just a scientific idea, it was a way of seeing humanity's place in the cosmos. Questioning this model was not merely a matter of astronomy, it touched on deeply held religious and philosophical beliefs of the time. For years, Galileo tried to navigate these treacherous waters. He argued that science and religion were not in opposition, but were two different paths to understanding God's work: science through observation of the natural world, religion through divine revelation. He wrote letters, engaged in debates, and tried to persuade theologians that the heliocentric model did not threaten their faith. But the forces of tradition were immense. The climate was changing, and the tolerance for new ideas was shrinking. In 1633, the inevitable came to pass. The aging Galileo, now nearly 70, was summoned to Rome to face the Inquisition. He was charged with heresy for defending the Copernican theory, which the Church had formally condemned as foolish and absurd in philosophy, and formally heretical since it explicitly contradicts in many places the sense of Holy Scripture. The trial was not a debate about evidence. It was an assertion of authority. He knelt and formally recanted his belief that the sun is the center of the universe. The image of Galileo on his knees is one of history's most tragic moments, a symbol of the conflict between science and dogma. But it is not the end of his story. Spared execution, he was sentenced to house arrest for the remainder of his life. Confined to his villa near Florence, his spirit, though bent, was not broken. Forbidden from writing about astronomy, he returned to the work of his youth, the science of motion. In these quiet, isolated years, with his eyesight failing, he dictated his final and perhaps greatest masterpiece, Discourses and Mathematical Demonstrations Concerning Two New Sciences. This book laid the groundwork for modern physics, exploring the principles of mechanics and the strength of materials. It was smuggled out of Italy and published in the Netherlands, becoming a foundational text for the next generation of scientists. Galileo died in 1642, still under house arrest, a prisoner in his own home. But ideas, once released, cannot be imprisoned. His legacy was not one of defeat, but of quiet, enduring revolution. His meticulous methods, the reliance on observation, experimentation, and mathematics became the bedrock of the scientific method. The torch he lit was passed on. In England, a young Isaac Newton was born the same year Galileo died. Newton would later build upon Galileo's work on motion and his astronomical observations to formulate the universal law of gravitation, finally explaining the mechanics of the heliocentric system and uniting the heavens and the earth under a single set of physical laws. Gravity. Galileo's story is not one of conflict, but of curiosity, a search for understanding in a world still learning to see. It's a deeply human story about courage, compromise, and the relentless human desire to understand our place in the universe. He showed that understanding the world begins not with belief, but with observation and reason. He reminds us that questioning what we believe to be certain is not defiance. It is how understanding. Galileo looked through his telescope and gave humanity a new cosmos. He replaced a small, comforting world centered on ourselves with a vast, mysterious, and infinitely more wonderful universe. And he showed us that the only way to truly see it is to have the courage to look. Thanks for watching. If you found this journey through history meaningful, consider liking this video and subscribing for more stories about the ideas that shaped our world. If this story made you think, Share your thoughts below. Don't forget to like, subscribe, and join us as we explore the minds that shaped our world.